today I'm going to talk about the dental x-ray tube head and how radiographs are produced. So to start, you have this metal housing of the x-ray tube head that has lead in it, and that's just going to help absorb any electrons or photons. And then next you have this insulating oil. It's in this tan color all the way around here, and that's just going to absorb any heat because there's going to be a lot of heat produced. Next, we're going to look at this blue outline right here, and that's going to be a leaded glass envelope, which is also going to absorb electrons or photons. So next we're going to look at this whole side, which is the cathode and is negatively charged, and this side, which is the anode and positively charged. And to break this one down, we have the focusing cup, which is going to help shape our electrons, and the tungsten filament. The tungsten filament is important because tungsten has a high heat capacity, and since there's so much heat produced, it's very vital for this. So once we turn on our tube head, we're going to start getting a lot of electrons and heat right here on this tungsten filament. Those electrons are going to start heating up and almost boiled off through thermionic emission. And when we go out and we press our button and we expose our radiograph, what we're going to do is we're actually going to send those electrons over to this tungsten target. And there's going to be so much energy, kinetic energy going on, that once these electrons hit here, they're going to be producing photons and also a ton of heat from that kinetic energy. And these photons are also, they can be over here, kind of going crazy, which is why we have that lead barriers going on. So once those photons are created, there's going to be this tube window, which is where we're allowing those to go through. They're going to keep being sent, and what happens is after we go through that tube window, we have this tube head seal, which is going to help with that oil, and then we have this aluminum disc, and this is going to help. See these low wavelengths? They're like long, and they're just slow. They're less penetrating than those high frequency short wavelengths that we want. So what's going to happen is this aluminum disc is actually going to eliminate those. So what we're left with is those short high frequency wavelengths. We want these and not the low frequency wavelengths, because those are just going to be absorbed into the skin and they're just going to be more harmful for our patients. So we really want to just have those high penetration power of the short wavelengths. We want to eliminate the amount of radiation our patients are getting. Also, so this is just to demonstrate that those would be absorbed here, and they also could be absorbed here. It is extended out into the PID, which is the position indicating device, which is going to help with that beam that we really want directed to that radiograph. And that's also helping with the shape, along with this lead collimator, which is also just eliminating the unnecessary photons that we really don't need. I'm going to go back and also talk about, I'm not sure if I highlighted this, but when those electrons are being sent, they also are going to this anode because it's positively charged and you have that opposite attracts. So that attraction is also why it's speeding up and being sent over. Another thing is that this turquoise kind of color is the vacuum. And so what happens is when we're sending those electrons, sometimes you'll have something like nitrogen that's just kind of in the way. So those electrons could be obstructed. So the vacuum is going to take out any unnecessary elements so that we get the best amount of electrons and just what we really want to focus on. Just pretty much the necessities in that point. And that's pretty much, so once you turn on your x-ray machine, you start getting those electrons that are here, they start doing that thermionic emission and getting boiled off. You go and you expose your radiograph, they get sent, they turn into those photons. You have those photons, they go through that tube window and everything else gets absorbed. And then they go through there. The aluminum disc is gonna switch out those low frequency ones, so we only have those high penetrating short wavelengths. And yeah, that's pretty much what happens when you expose a radiograph.